Question 7 is a bit of an extension, a bit of a puzzle here for you to try and work through. And we're going to try and work out the expansion for this thing here, and it being all algebraic, this is going to be interesting. So we'll start with 1 to the power of n, and that's fine. And then we've got n choose 1 times by 1 to the power of n take away 1 times by kx to the power of 1. We do actually know what that is. We know that anything choose 1 is just the n value. We know that 1 to the power of anything is just 1, and we know that that is just kx. And so that one simplifies really nicely. Shame it's not one of the ones we wanted then, really, isn't it? Then going on to the n squared then. So we've got n choose 2, 1 to the power of n take away 2, and then I've got a kx all squared, and then I've got n choose 3, 1 to the power of n take away 3, kx all cubed. Now these are the important ones that we've got to work on. We need to go back to our original definition of what the combinations thing was, and the factorial definition of that was that it was n factorial over n take away 2 factorial 2 factorial. This is just 1. Then I've got k squared x squared. And with this one here, a similar idea. I've got n factorial over n minus 3 factorial, 3 factorial, 1 here, and k cubed, x cubed. The next bit of tidying up I'd do is this bit here, is that n factorial, I'm just working this out. If you did 10 factorial over 8 factorial, you know that 10 factorial is 10 times 9 times 8 times 7, blah, 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 blah. And 8 factorial is 8 times 7 times 6, blah, 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 blah. You'll notice that this bit here all just cancels out. And so all we're left with here is n and n take away 1. So my whole bit here is going to cancel down to n times by n take away 1 over 2 factorial, which is 2. And I've got k squared of those there. This one here is going to cancel down to n take away 1, and another one, n take away 2, because this one, the bottom there doesn't start cancelling till n take away 3. 3 factorial at the bottom there is 6, and we've got a k cubed there as well. They are the two coefficients, and we've been told that the coefficient of x squared is half the coefficient of x cubed. So if I times that one by 2, they would both be exactly the same. Now, let's do some cancelling. Those 2's cancel there. Divide both sides by n, does that. Divide both sides by n minus 1, does that. Divide both sides by k squared. Everything's gone over here, leaving me with 1. There's a k there, and we've got that. So what are we aiming for? If we times by 6 up here, and we divide by n minus 2, that gives the k there. And that's what we were trying to prove, and that is a very nice result. To try and think about which different values could they be. I mean, I'm actually just going to go through them. If n is 1, well, that doesn't work, does it? Because you can't have that. N is 2 would make this 0 on the bottom, so we can't have that. N is 3, well, that's okay. 3 take away 2 is 1. That gives us a k equals 6. So there's a possible answer. N equals 4, that works as well. 4 take away 2 is 2. 6 divided by 2 gives k is 3. N equals 5. That's okay as well, isn't it? N equals 5. 5 take away 2 is 3. 6 divided by 3 gives me k is 2. Now, if I put 6 in there, that wouldn't be a whole number. If I put 7 in there, it wouldn't be a whole number. If I put 8 in there, it would be, wouldn't it? So the last one I think I've got is n equals 8, which then gives you 6 divided by 6 is 1. So I think these are the different possibilities. Anything else, they would not be integers. They would not be whole numbers.